All right, let's jump right in. We're talking about something called the Model Context Protocol, or MCP. And honestly, the best way to wrap your head around it is to think of it as the USB-C for AI. Yeah, it's that big of a deal.
Seriously, just for a second, picture that. A world where your code editor can just talk to your chatbot, and that chatbot can talk to a financial tool, and none of it requires some custom, messy wiring. That's the kind of world we're diving into today.
So what is MCP, really? Well, at its heart, it's a standard interface, a universal translator. See, large language models are brilliant, but their knowledge is stuck in the past, limited to whatever they were trained on. If they want to do anything useful in the real world, like, check today's weather or read a file from your computer, they have to connect to outside tools. MCP is the standard that makes those connections dead simple and universal.
But you might be thinking, why do we need a whole new protocol for this? Well, to really get why MCP is so important, you've got to understand the problem it solves. And trust me, it was a total integration nightmare.
This image says it all, doesn't it? On the left, that's the world before MCP. If you had M AIs and N tools, you could end up needing M times N unique connections. It's a complete mess, a web of spaghetti code. Now look at the right. With MCP as this central hub, everything just plugs in once. It's clean, it's organized, and most importantly, it actually scales.
Let's put some real numbers on it. Let's say you have just 3 AI apps and 3 tools you want them to use. That's 9 custom integrations you have to build and then maintain. Every time you add one new tool, you have to go back and build new connections for every single AI. It's an absolute headache for developers.
But with MCP, the math just flips on its head. It's not multiplication anymore. It's addition. You connect your 3 AIs to the standard, and you connect your 3 tools to the standard. That's it. M plus N. 6 simple, standard connections instead of 9 tangled, custom ones. All that complexity just vanishes.
Okay, so we get the why. It makes everything way, way simpler. But how does this thing actually work under the hood? Let's take a quick look at the architecture.
It really boils down to 3 main players. First, you've got the host. This is the app you're actually using. Think Claude Desktop or the Cursor code editor. Then you have the client. You can think of the client as the messenger. It sits inside the host and it knows how to speak the MCP language. And finally, there's the server. This is the external toolbox where all the cool extra functions live.
And what's inside that toolbox? Well, 3 main types of things. First are tools. These are actions the AI can perform, like fetching the weather. And what's key here is that the AI model itself usually decides when it needs to use a tool. Then you have resources. This is read-only stuff, like the text in a file. The main app, the host, is usually in charge of giving access to these. And finally, you have prompts, which are basically pre-built workflows that you or a developer can use to guide the AI.
All right, the theory is cool and all, but this is where it gets really fun. What can you actually do with this protocol? Let's check out some of the AI superpowers that MCP is already making possible.
First up is something that pretty much every developer has been wishing for, the ability to create a shared memory between totally separate apps.
Get this, you're in the Claude Desktop app, chatting away, telling it key facts about a project you're working on. Then you hop over to your code editor, Cursor, and ask its AI assistant a question. Instead of starting from 0, it instantly knows everything you just talked about with Claude. How? Because an MCP server, in this case from a project called Graffiti, is acting as a shared memory layer between them. It's a complete game changer for workflow.
Okay, superpower number 2. What if you could have your very own personal research team that could do a deep dive on any topic, and it all runs right there on your own machine? And this is the amazing part. It's not just doing a simple web search. MCP allows different AI agents to work together as a team. One agent searches the web, another analyzes the results, and a third writes up a report. The whole system gathers information, checks sources, gets rid of duplicate info, and then writes a final clean report with citations. It's like having an expert research team on demand.
And for the last superpower, we've got something that feels like it's straight out of a sci-fi movie. Being able to search inside a video.
I mean, think about that for a second. You've got this hour-long recording of a company meeting, and you just need to find one little piece of info. With an MC-powered tool, you can literally just ask the video a question. The system uses a technique called RAG, which basically lets the AI search through all the content of the video to find the most relevant part.
It then pulls up the exact timestamped clip you need. This is a fundamentally new way to interact with media.
So we've seen shared memory between apps, deep research agents, video search. After seeing all these incredible applications, what's the big takeaway here?
And this right here is the most important thing to grasp. The Model Context Protocol is so much more than just some dry technical standard. It's a foundational building block. It's creating a common language that's going to let all our AI tools and apps finally connect and collaborate in ways we're just now starting to dream up.
And that's really the question MCP leaves us with. When connecting things is no longer the hard part, when any AI can tap into any tool, what new superpowers are we going to unlock? What incredible things are we all going to build when every AI can finally and truly work together?